Derivatives of logarithms and e. The next set of functions that we will examine are exponential and logarithmic functions, which have their own set of rules for differentiation. First, let's consider the exponential function e to the x. At first, it appears that the power rule may be an option. Unfortunately, it will not apply to this function because the exponent is not a fixed number. Instead, it's a variable. And the base is also not a variable. It's a constant value of 2.718 approximately. Let's take a quick look at the proof for the derivative of e to the x. If f of x is equal to e to the x, then f prime of x is equal to the limit of e to the x plus h minus e to the x all divided by h as h approaches 0. Now, by the rule of exponents, we can rewrite this limit as h approaches 0 and the rational expression that we have here as e to the x times e to the h, and then minus e to the x all over h. Notice we have an e to the x that we can factor out, and when we do so, we have e to the h minus 1 left in parentheses, all divided by h, and we're finding the limit of that as h approaches 0. We can move e to the x out in front because there is no h involved with it. We write it as e to the x times the limit of e to the h minus 1 divided by h as h approaches 0. And this ends up becoming 1. So we have e to the x times 1, which is equal to e to the x. Graphing is also helpful for further understanding why the limit of e to the h minus 1 divided by h as h approaches 0 is equal to 1. And let's actually do that. Let's look at the graph to see why this is the case. So if I switch over to the graph, here is that function. And as we travel along it, as we get closer and closer to h being 0, my y value is getting closer and closer to 1. Notice at 0 it's undefined there. And then as I approach it from the right-hand side, it's getting closer and closer and closer and closer to 1. So that is why we are able to cancel it out while simplifying and have it be equal to 1. So we can see that part of the difference quotient simplifies to 1, and therefore the derivative of f of x equals e to the x is e to the x, which is a pretty cool derivative to have. It just stays the same. The proof for any exponential function in the form of a to the x is similar to that of e to the x. However, the part that simplified to 1 before will not this time, but will instead simplify to the natural log of a. Therefore, the derivative of f of x being equal to a to the x, where a is any real number, is f prime of x is equal to a to the x times the natural log of a. Let's find the derivative of f of x being equal to e to the sine of x. The first step when finding the derivative is to know that the derivative of e to any exponent is e to that exponent still, but then because our exponent is sine of x, we have to apply the chain rule and take the derivative of sine x, which is cosine x. The final step is to simplify. We can't necessarily combine, like add or subtract any terms together. These two terms are being multiplied, so we can simply rewrite them as f prime of x is equal to e to the sine of x times the cosine of x. The derivatives of logarithmic functions are given below. The derivative of the function y equals log base a of x, where a is a real number, is f prime of x is equal to 1 divided by the quantity x times the natural log of a. And the derivative of the natural log of x is f prime of x is equal to 1 divided by x. Let's try an example with logarithms. Find the derivative of f of x, which is equal to the natural log of the quantity 4x squared. The first step is to set up the chain rule. So we have the natural log of 4x squared. So the derivative of natural log is 1 over whatever's inside of that set of parentheses. So that's where we get the 1 over 4x squared. But then we have to apply the chain rule and also take the derivative of what's inside of the parentheses, or what's inside of that logarithm. And the derivative of that is 8x. The final step is to simplify. We would have 1 over 4x squared times 8x. We put that over 1. We can see why we have 8x divided by 4x squared. And then 8 divided by 4 is 2 over 1. And then x divided by x squared is the x in the denominator. So our final answer here for f prime of x is 2 divided by x.